So one of the most interesting problems while designing any system is, hey, which database should I pick? Right? Okay, first of all, it's not a fight. No need to pick a side. No need to have a favorite DB that, hey, I'll always use this particular database, right? So always remember, whenever a database is created, the creator creates the database thinking of solving one problem really well. Well, if someone is writing a very fast in-memory key value store, the use case is very different. That, hey, I want people to use this as a cache or use it for advanced data structures. That's where Redis was created. Right? Someone creating a database where they want high consistency of data, integrity of data, they think it's relational databases, right? So whenever a database is conceptualized, it's conceptualized to solve one problem really well. So what happens is each database picks a small niche, and there might be databases that overlap in those niche, right? But it's okay, right? So first of all, you should know what you're looking for, and then you pick a database. Okay, there is a common misconception floating. It says that, hey, I'll pick non-relational DB because relational databases don't scale. It's a very bad way. It's a worst justification to a design decision. That I'll pick a non-relational database because relational databases don't scale. No, I can give you 1,000 examples where relational databases have scaled brilliantly. I'll give you 2,000 examples where non-relational databases failed to scale, right? Because it's not as simple as this one singular statement, right? So let's understand why non-relational databases scale when people say they scale. So non-relational databases are able to scale because they do not have relations or constraints. For example, in a relational database, you can have a foreign key relationship where you have a parent, you have a child. You cannot create a child without that parent existing, right? So for example, if you're creating a post with a user ID, you cannot add a user ID that does not exist. Your database would not let you enter or let you create that row. Right? That is the thing that we are playing with. So because these are strict constraints that relational databases give you, they don't want, like, they would not work if your data resides on two different databases. How can you check for parent that resides in another database and child in other database? You cannot typically do that, right? So which is where your non-relational databases, they don't offer you those constraints. So then obviously you would scale, right? Okay. Now the data that is modeled, because non-relational database, the way they define access pattern, they start with an assumption that your data is distributed across nodes, which means that you would never be accessing data that requires you to make cross-shard queries. They start with this assumption. Now, if you think about it, you can do that exact same thing on a relational database. And what if you just drop the foreign key checks? You design your model such that you don't have any foreign key checks, and you don't have any cross-shard transactions, or you just do manual sharding, right? Because NoSQL database gives you out of the box sharding. They don't let you do cross-shard queries. You also don't do cross-shard queries on relational database, and you drop foreign key checks. Then you are actually sharding a relational database, and you can now horizontally scale them out, right? So that is where it is very important to understand that when someone says that I'll use non-relational databases because relational databases don't scale, it means that a person actually does not know why that is even a statement, right? Because that is not completely true. You need to understand why a certain thing about a certain kind of database even exists, right? And can you change your existing databases to tune that? For example, we know why non-relational databases scaled. What if we drop the things that made relational databases not do that part, and you do it, and then relational databases scale out, right? This is what I wanted to probe you all to think in those lines, ask those critical questions to understand, to challenge the underlying principles of a database. When you do that, you're in a very strong position to have a very good justification on why you're doing what you're doing, what's happening behind the scene. Okay. Now, does this mean that all databases are same or no DB is different? No. Every database has some peculiar properties and guarantees that only those databases provide. For example, Redis is known for advanced data structures. Redis is known to be in-memory database that you can use as a cache. You will not choose to use MongoDB for that. because MongoDB does not give you that. Redis has that peculiar property of advanced data structure. Neo4j has peculiar property of graph algorithms, right? Then DynamoDB has peculiar property of storing data in a very sharded manner, key value based access, right? So every database has a unique thing. And now as an engineer, you need to know different kind of databases which are there to be offered to you. You need to know the core properties that they give you so that you can make a better decision. Now, how does this help in designing our system, right? That's where everything boils down to. So while designing a system, always remember, never jump to a particular DB right away that, hey, I'll just use this database. I don't want to think of any other database. No, don't be adamant on a certain design decision. Be very open-minded. First, what you need to do, you choose a database, you select a database, the last thing. You understand the properties that you need from the database, and then you make a selection that, hey, this is a database that fits it really well, so I'll use this database. Okay, what are the questions that you would ask? First, understand what data you are actually storing in the database. Is it structured? Is it semi-structured? Is it totally unstructured? What kind of data are you storing? How much of the data are you storing? If it's too much data that OneNote definitely cannot handle, then you need sharding out of the box. You cannot spend time sharding things, right? If the data is too less, you can just store it on one machine. Then why do you need sharding? Why would you pick database that gives you sharding, right? Don't, like, your answer should not be just in case. If your data can never grow 1 GB, grow beyond 1 GB, why would you even think about that? Right? Understand how you would be accessing the data. What is your access pattern? How are you querying the data? Do you want complex queries or not? Right? And then any special feature that only a certain database gives you. For example, expiration, for example, Bloom filters, for example, hyperlog. Depending on those, you would pick a right database. Now let me walk you through on different situations and then which database would we pick. It would clarify the entire picture. First, if the data can fit in a single node, right? If a data can fit in the single node and you need strong consistency, and data correctness is super important, right? You need strong consistency of data and you need data correctness of it. For example, payment system is a classic example of that, right? You go for relational DB. Relational databases suit this use case perfectly well, where you need very strong consistency of data. No matter what happens, your data should never go in an inconsistent state and your data should always be correct. Relational databases fit this really well. So if your data can fit in one node, you need strong consistency, you need correctness, you go for relational database, right? Second, if your data can fit in one node and you need complex queries like aggregations, complex queries that you're firing, you need views, stored functions and something like that, right? But your data can fit in one node, relational databases is your go-to option because it solves a lot of problems for you. You pick any other database, it would not have those rich features because relational databases over this 50 years, they have grown into such battle-tested products. 50 years, yeah. They've grown into such battle-tested beast that can solve literally any problem out there, right? Okay. But now if let's say your data can fit on one node and you want key value based access and you want it to be really fast, right? So when you know that you want it to be really fast, then you cannot do disk IO, which means data needs to be there in memory, given its key value base. So key value in memory database, Redis. You go for Redis as your database. Now, for example, if you need advanced data structures, that because very few databases actually offer that in today's day and age, so you go for Redis because Redis gives you those things. Because typically when you need an advanced data structure, that becomes like a must-have for a database. So you would typically go for database that gives you that. So Redis is the way to go. Now, for example, if your data does not fit in one node, which means that the amount of data that you are storing is huge enough that you cannot fit in one node. Then let's say you don't have expertise in SQL and you have expertise in SQL and you can do manual sharding. Then you go for relational DB by dropping the constraints. So you say, I'll not have foreign key checks. I'll not have anything. I'll shard my relational database and I'll do manual sharding. So my API server would know which database to connect to. So I can, but me and my team have expertise in SQL. So you'll go for relational DBs. So this is where I'm fitting in relational DBs where even one node is not able to handle the data, right? This is a classic place where you may think, hey, I'll go for non-relational DBs, but I'm still choosing relational DBs because me and my team have expertise in SQL. So I don't want to spend time learning a new database. I can just leverage the existing database, the existing expertise that I have, and just use relational databases for my purpose. And a lot of companies actually do that. Now, for example, if your data cannot fit in one node, but you have simple key value based access, right? Data cannot fit on one node, you have simple key value based access, you go for DynamoDB or MongoDB. But you say, my MongoDB is document based data. Don't use document based things, right? Just store normal value in that JSON thing. Problem solved, right? Here you see how I'm piggybacking one database, one class of database into another. This is what I wanted you to think about, that it's not a very strict line that is being drawn, right? You have simple key value based access, one node cannot hold the data. So anything that is sharded and persistent, you go for that. DDB, MongoDB, pick your favorite, right? Now let's say if you require very sophisticated graph algorithms, you have no other option but to go for graph database. So Neo4j, dgraph, pick your favorite. If you have nothing specific, no specific requirement, but you don't know what lies in the future, but you may think, hey, I might need it in the future, but it's definite that I don't want to use SQL, because it's not that I have very deep SQL expertise, but it's just that I know my data is huge. It definitely needs to be sharded. So I need sharding out of the box, but I don't have any specific requirements, but I just want to be future proof. You go for document based databases like MongoDB, right? This is very high level idea on how we are picking the data. And basically, by the way, this is how I operate. Like, I've seen people operate exactly this way, right? Because it's not that difficult. When you know how a database actually works, you don't need to know exact core internals of it, but even a rough idea gives you this very nice framework to think about, right? So I just leave you all with this thing, that don't pick a side, don't pick a fight with a particular DB. Every DB is special. Every DB has a peculiar set of properties that it adheres to, and you just want to know how to leverage it, right? So what I would recommend is pick your favorite databases, play around with them, see how you can fit one type of database into another type of database. It's a very fun exercise. Be creative, be explorative, be very curious on what you're playing on, and you'll for sure have a time of your life, right? And yeah, this is all what I wanted to cover in this one. I hope you found it interesting. Hope you found it amusing. I'll see you in the next one. Thanks a ton.